Good afternoon, everyone. Just want to say thank you for attending our webinar. We're going to wait one more minute before we kick off just for some last-minute stragglers. All right, let's get started. Just wanted to thank everyone real quickly for coming to our webinar. Today, we're going to talk about ice pigging as a service and its application in Naperville, Illinois. You're going to be hearing today from Tony Kahn, who's the head of utilities at Naperville in Illinois, and Paul Trelaw, who's the head of ice pigging at American Pipeline Solutions. My name is Blake Murphy. I'm the president of American Pipeline Solutions. I'm doing a quick intro and talking about our company. We are a nationwide pipeline services company. We specialize in ice pigging and foam pigging for pipeline cleaning, as well as pipe mapping and smart pigging, which is condition assessments. We plan on providing a webinar, roughly one a quarter, just on different technology that's emerging in the sector, as well as some of our service offerings. Our goal is to pair each of these offerings and technology with someone who's actually utilized that technology in the past, just so you're not hearing from the service provider, you're also hearing from the client themselves, such as Tony Kahn. So without further ado, I'd like to hand it over to Paul Trelaw, our head of ice pigging.
Hey everybody, Paul Trelaw. I come from the UK, born in England, joined the Marines out of school, and after the Marines joined Bristol Water, where ice pigging evolved sometime after I joined, and that was my relationship and how I got into ice pigging. Came over here with ice pigging with a company called Suez in 2012. And moved down to Florida and joined American Pipeline Solutions in 2020 when they took over the ice pigging services. So, Tony, I'll let you introduce yourself.
Thank you, Paul. Good afternoon, everybody. As Paul and Blake said, my name is Tony Kahn. I'm the Deputy Director of Public Utilities, in charge of water operations for the city of Naperville. Water operations meaning water supply, water distribution, wastewater collection and pumping, and stormwater pumping. This is my 33rd year with the city of Naperville. I got 40 years of experience. I don't like advertising that, but in the water industry, certified water, IEPA, Illinois Environment Protection Agency, certified water and wastewater operator. Also NASCO certified in PACP, LACP, MACP, and both of the ITCP manhole rehab and cured in place inspections. Member of a lot of trade organizations and also a member of the Illinois Water Environments Collections Committee. Quick overview of the city of Naperville. City of Naperville is the fourth most populated city in Illinois. We're located about 28 miles west of the city of Chicago. Naperville also has one of the largest combined utility system, meaning of both water distribution and sanitary sewer collection systems, and we own our own wastewater treatment plant. Quick overview of the city of Naperville's collection system. We have just under 567 miles of sanitary sewer main, 14,085 manholes in our system, 23 wastewater lift stations. Of those 23 wastewater lift stations, there's 26 force mains, meaning some of our largest pump stations have 2 force mains leaving them. We also have 44,000 customers, and we serve a population just shy of 165,000 people. And we also serve the wastewater for one satellite community. Little background. As we all know, force mains are a critical asset in the wastewater collection system. and they're often overlooked. In 2021, the City of Naperville Water Utility did a pilot program to perform a internal condition assessment of the force mains that were force main that was installed in the 70s. Keeping in mind the station was originally an old dry pit station that was converted into a submersible station. Excuse me. Working with a collection system engineering firm, and after reviewing several technologies, we decided that the Ingu Piper system would be the best system to perform the internal inspections of all the force mains and get our deliverables that we were looking for. The Piper is free floating, detects leaks, looks for air pockets, looks for gross wall thickness changes, pressure differentials, and blockages. And with the pilot and the other programs that we used with the Ingu Piper, we found considerable amounts of debris in actually all of our force mains. A little background on the Cinnamon Creek lift station. This is the first lift station that we originally did a pilot on. This station force main was installed in the 1970s. Excuse me. The pilot was performed using, again, the Ingu system, and that, I'm sorry, I'm fighting a sore throat. That pilot system, we discovered that the force main was reduced by 10%. More or less, it had a pretty good sized debris buildup in the force main. In 2021, the following year in 2022, we did perform the same test on Country Lakes lift station. In that one, we also found a 16% of debris buildup in that force main. In the chart in the table in the middle, you can actually see what you receive from the Ingu Piper. It's capable of pinpointing where in the pipe, linear footwise, where the debris starts, kind of calculates the percentage of the debris and all the way to the end of the pipe. After doing this work, it was reviewing all the data and everything. It was determined that ice pigging would be the most cost-effective way to remove that debris. We reviewed the data and some case studies for traditional pigging and some of the information for ice pigging, and we decided to move along with the ice pigging program for both force mains. American Pipeline Solution was the sole provider in North America, so we worked with them for the force main cleaning ice pigging program.
Thanks, Tony. So what is ice pigging? We like to call it advanced pipe cleaning technology. Of course, it improves water quality when cleaning drinking water, as it was developed on drinking water. And of course, it's going to improve water quality. In sewer force mains, it's more of a tool for increasing flows and improving pumping performance, etc. So it was developed by a guy called Professor Joe Carini from the University of Bristol. And he came to the company I was working with, as I said, Bristol Water, a water supply company, and said he had this idea to using ice to clean underground pressure pipes. And he wanted to use Bristol Water's underground infrastructure, their assets, to practice and develop this technique. And that's what happened. This is going back over 20 years ago now. I was not part of it initially, but I was watching from the sidelines as several of my colleagues were involved in this, and I had great interest in it. And I got involved once the technique had been perfected, and it was then put under a license for the use of cleaning, using ice to clean pipes was a patented process. And as Blake said earlier, Tony said, American Pipeline Solutions are now the only company offering it in the USA. It was introduced in 2012 when I came over here from the United States to introduce ice pigging, and I've been here ever since overseeing it. So how does it work? So we have this semi-solid material that can be pumped like a liquid. And you see that glacier there I want you to think of of an ice pigging project. When we inject the ice into a pipe, it doesn't so much bulldoze or snowplow that any sediment or grease and fats and oils in that pipe. It doesn't push them up front like a solid mechanical pig would, but it more like picks them up in the body of the ice, much like a glacier going through, forming valleys and picking up rocks and stones as it moves through. Because we have this semi-solid material that can actually be pumped like a liquid, um, and but it behaves like a solid when it's in the line. And by that, what I mean is once we pump the liquid ice into the pipe, it forms as a pig. We don't look to fill a pipe with ice. We don't have enough ice for that. As long as there's enough ice to go from the injection point to the predetermined discharge point before it all melts, and then that's fine. So we're usually looking for a certain percentage of any pipe dependent on pipe material and pipe size. We can then figure out how much ice we need for any pipe that we're trying to clean. So how do we do that? Well, we have to control it. Obviously, if we'd froze water on its own, then it would be solid ice, and we couldn't pump it, or it'd be very, very difficult to pump solid ice around the system. So we had to come up with a freezing point depressant that was going to be safe for, it had to be NSF approved because initially, as I said, this was developed on drinking water. So we came up with food grade table salt, and we could make a brine solution, and we were able then to freeze this down to about 24 degrees. So it was really cold in the pipe. And the colder it is, then the longer it's going to last as ice, and the further it will travel, and we'll get more cleaning coverage per each batch of ice that's made. And of course, because it was just food grade table salt, always mixed with fresh potable drinking water, it was going to be harmless to customers should any get up into their service lines. So ice pigging, I'm not going to sit here, none of us will sit here and tell you that ice pigging's the perfect tool and it's the silver bullet of pipe cleaning, because it certainly isn't. But it's a very, very good tool to have. It's a very useful tool to add to other tools like mechanical pigging, jetting, etc., or hydrojetting and mechanical conventional pigs. But the benefits are, with ice pigging, or some of the benefits is, for a start, it's easy to get access into the pipe. We nearly always use existing fittings on the pipe. To get the ice into the pipe, because it's just like a liquid, we just need a 2-inch port. So quite often we'll use a fire hydrant, a blow off, a clean out, a pump bypass, an air release valve. We can unscrew an air release valve and screw our hose onto that. So there's always usually existing fittings to allow us easy access to get this ice into the pipe. The ice will pass through plug valves. Many force mains are fitted with plug valves that become an obstacle for conventional or mechanical swabs or pigs. It doesn't matter to the ice, much the same as a butterfly valve on larger transmission mains. In the drinking water side, conventional pigs tend to not be able to pass through these, but the ice will pass through because it really is just like that liquid. And it adapts, because it is like a liquid, it adapts to change in diameter. So think of a situation, you're trying to clean a pipe that may change diameter 1 or 2 times for different reasons. And this may pose a problem for mechanical pigging, where you need a specified pig size or swab size for each individual size pipe. It doesn't matter to the ice. The ice is, as I said, as I keep saying, it's like a liquid. It just adapts to the change in diameter as it passes through the pipe. And it's guaranteed not to get stuck. What I should add to that maybe is permanently, every now and again, that the ice gets pumped in, maybe packed in a little too hard, and it might stick for a little while. But hey, we just wait a little while, it starts melting immediately, and then it moves on its way and starts cleaning. So, as I like to say, we're not going to spoil your weekend by getting a pig stuck on a Friday afternoon, and then you got to go and dig it out and look for it. It just doesn't happen with the ice because it is just ice, and the worst thing it can do is just melt and then get flushed out of the system. And so because of those things, there's very short downtime. Because of those things I've mentioned previously, with an ice pigging project, there's very short, very minimal downtime, especially on sewer force mains. In fact, when we inject the ice into a sewer force main, we can inject the whole 10 tons that we make each night in 20 minutes. So the longest time that a sewer force main would be out of service in an ice pigging operation is just purely 20 minutes maximum while we inject the ice. And I'll talk about that shortly in another slide. More benefits, the cleaning capabilities. Well, if you think of drinking water, iron, manganese, sediments and grit in sewer force mains, biofilms, fats, oils and greases, all these type of things, all the things that you associate with normal underground pressurized pipes in the utilities, and then ice pigging is generally going to be a very good tool to remove all of these things. The equipment, I just want to show you some of the equipment here. We have our ice tanker, which carries the equipment, and the ice machines are on a separate trailer. You can see a bank of ice machines there. And in ice production mode, the tanker on the left there, you can see, is filled up at a local fire hydrant with drinking water. We add that food grade table salt to it, and then it's connected up to the ice machines. You can see here on the right hand side these white upright cylinders, and you can see these flow and return hoses here. So once we have the brine filled up in this tanker, we start the ice machines. They suck the brine out of the tanker up through their cylinders, and they return that as slush ice into the tanker. You imagine initially all that does is just start chilling the water that's in that tanker. But over a period of anything between 7 and 14 hours, maybe sometimes even a little longer, depending on the ambient temperature and depending on the starting temperature of the water that we take from a hydrant, which down in the southern states can be quite high sometimes. So anything between 7 and 14 hours it takes to make a batch of ice. Once the ice is ready in the morning, this happens through the night, and then in the morning we have this 10-ton batch of ice, 2,700 gallons, ready to go out and deliver remotely to site, where we'll have already identified the correct place to inject the ice in at. So real briefly, how we set up on a sewer force main. This is a very basic drawing of a sewer force main, and you can see our tanker here. A force main, by definition, is forcing and has to force or pump or push any of the solids or liquids uphill to maybe a collection chamber, and maybe into a gravity system that takes it on its way, or maybe at the treatment plant. So all we need to do is, once we're connected up with a simple 2.5-inch fire hose. This is simple diagrams, but this could be a pump bypass. It could be an air release valve. We just need that 2-inch port to be able to connect the ice hose to. We switch off the pumps, then we inject the ice in. So the ice gets injected into the pipe. It can't go back down into the wet well because, as you know, there's gonna be check valves there around the pumps to protect that. So the ice just forms in this pipe. And is then ready. Once all the ice is in there, it's ready then to be pushed through the system. So the lift station pumps are then turned on, and it's the wet well contents then that push this ice all the way through until it gets right through to the end of the system. So really quick and easy, simple method of cleaning sewer force mains. And as I've said before, it's really very low risk because there's no risk of blockages. That's what it actually looks like. You can see our tanker there in the background, and the pipe is running around out of view here, but that's connected up there. This is on I don't know, I think this is maybe a 16 or 12-inch sewer force main, and this is a pump bypass arrangement here. So our hose was just connected up to a drilled flange here, and it's easily pumped into the system. So no modifications were needed. So that's really how ice pigging works. I'm going to hand back over to Tony now, and he'll talk through the the project at Naperville?
Thanks, Paul. The planning and execution portion of both the Cinnamon Creek and Country Lakes force mains, how that really worked was we gave our pump data to APS so they could calculate how much ice slurry is going to be needed for each force main. The Country Lakes force main is about just over 2,300 linear feet of 6-inch ductile iron pipe. APS calculated about 1,200 gallons of ice slurry would need to be used, and it was injected into the force main through the station's existing 4-inch bypass located inside the check valve pit. You can see that in the center picture. And the picture all the way to the right shows APS operations injecting the ice into the force main via that bypass. How it really works is this: right before we start pumping ice into the force main, the lift station's turned off. We allow the lift station to surcharge, the wet well to surcharge, to make sure we have enough water to push the ice downstream to the discharge gravity manhole using the existing pumps. So no special equipment other than the ice machine supplied by APS was needed. The entire process, once the ice was injected into the force main, the pumps were turned on. The existing wastewater and the wet well was used to force the ice downstream to that discharge manhole, cleaning the force main, and the complete time that it took from setup, traffic control, shutting things down, took just about an hour. Very similar process with the Country Lakes force main. This is about 1,100 linear feet of 10-inch PVC force main, where APS injected 1,500 gallons of ice slurry into the 6-inch bypass. Same exact thing. The pump station was shut off, allowing the wet well to fill up with wastewater. So when we were done injecting ice, we had more than enough wastewater in the wet well to, when the pumps were turned on, to force the ice slurry down through the force main to the discharge manhole. Again, this entire process, traffic control setup was a little bit longer because we had to get some fittings to knock the 6-inch bypass down to fit the APS hoses. It took about an hour and a half. So relatively, both of them, very minimal time cleaning these force mains for the great benefit that we received. Results: the Cinnamon Creek force main, pre-drawdown test, so pre-cleaning test, and it was also confirmed with the in-line flow monitor. We were pumping normally about 301 gallons per minute. This is pumping left of the design curve. And our run times were running about 1.1 hours per pump. After the force main was cleaned, for several days, we monitored how much flow the pump station was able to perform now. And we were able to pick up all the way up to 372 gallons per minute after the cleaning, which put us right in the middle of the most efficient pump curve port of these pumps, and knocking our pump time hours down to 0.8 hours a day. Bottom line is our flow increased about 20% and our run times decreased about 20%. Very, very good numbers. Similar with our Country Lakes lift station, before the cleaning, the pumps were pumping at 1,100 gallons a minute. These pumps were pumping way left of the curve. And if you understand pumping left of the curve, how much damage that can do to a pump, actually equaling premature failure of the pump system, it was very concerning to us. And also, these pumps were running 5.4 hours a day. But after this force main was cleaned, we did for several days several post drawdown tests, and we gained quite a bit of flow. We were up to 1,380 gallons a minute. That's exactly the design curve of this pump station. So we brought our pump station back up to its original design curve while knocking our run times down to 4.3 hours a day. Again, flow increased 20%, run times decreased by 20%. Conclusions to our test: we were really, really pleased with the ice pigging, how easy the ice pigging was, how it was able to restore the pump stations to its peak operating performance. Both stations, when the ice pigging was completed, were pumping well within their high performance of their design curve. It reduced pumping cost, not consuming much electricity, increasing the life of the pump equipment. We're doing less maintenance on it. Pumps are doing less run times. Again, reducing electricity, not needing to unclog these pumps as much as necessary when they're running all those times. The nice thing about it is the project came in about $32,000 under the estimated cost for traditional pigging. And that's actually just the cleaning portion. There's other things you have to do for traditional pigging to get it ready for traditional pigging that we did not need to have to do for cleaning these force mains using the ice slurry. Or we were so successful with both the INGO inspection and the ice pigging program. Naperville, we developed a force main cleaning and inspection schedule that incorporates both ice pigging, traditional pigging, smart pigging, and depending on the situation of the force main, is going to tell us what technology we're going to use in the near future to keep all the force mains clean.
All right, thanks, Tony. Right now, we just want to open it up for Q&A. So if you have questions, please drop them into the chat and we'll get to them in the order that they come in. So the first question we've got is, do you have to completely drain your force main before pumping ice into the pipe, or can you pump ice against the head at the connection point?
No, that's exactly, if I can pick up there, Blake, that's pumping against the head of the water that's trying to fall back towards the force main, towards the wet well, is exactly what we want to do. If we were to drain the pipe, and then we'd struggle to form an ice pig in the pipe. So we're always looking to pump in against a pressurized wall of water, if you like, for want of a better term, to make sure that pig forms properly.
Gotcha. Thanks, Paul. Tony, I think this one's for you. Did you calculate a return on investment, like the number of years to get payback on cost of pigging?
Yes, we did actually. We're lucky enough that we track our pump maintenance, electrical consumption, and everything through our CMS system. So that data was relatively available. So we calculated what the pump station is doing now compared to what it was doing before. And our return on investment is about 9 months.
So your break-even point's at about 9 months?
About 9 months, yeah.
Gotcha. That's fantastic. Paul, this one's for you, also from Joe Hoffman. Does the salt present a risk to the bugs at the treatment plant? Or maybe that's actually for Tony, or either one.
I can tell you, I'm not responsible for the wastewater treatment plant, but I did talk to my partner, Deputy Director Joe Slubnik, at our Springbrook Water Reclamation Center, and it does not. It's like any other project. Before we introduce anything into our collection system, we discuss it with our treatment plant to make sure we're not going to harm the operations of the treatment plant. And the salt that was being used would be so diluted by the time it got to the treatment plant, it would not affect the bugs.
Yeah, and I'd like to add to that, Tony, that and that is something that we always do. It's certainly, you're correct to bring that point up, and thanks for that, for raising that point. You certainly do need to have a conversation with the treatment plant manager. We tell him how much salt is going to be introduced into the pipe each day. But as Tony said, it's nearly always a case of there's so much dilution that it has little to no effect whatsoever on the treatment plant process. But if it were a very small plant that wasn't taking much in per day, and it was deemed to be going to be an issue, we would always find ways of intercepting and collecting the salty water in a wastewater vacuum truck or tanker, and disposing of it safely that way. But so there's always a way around it, but we've hardly ever needed to do that because of the dilution factor.
Perfect. Thanks, Paul. Next question, this one's for you, Paul, is are there bend limitations on pigging?
If we're talking about ice pigging, none whatsoever. As I said, this is just really like a liquid. It's a slush ice, much like your kids' drinks. If you think of the Slurpees or slushies, that's the sort of consistency of the ice. It'll go around any number of bends. Wherever the liquid flows, this ice is going to flow. I assume that question was aimed at ice pigging.
Yep. Jordan Crane wrote, what kind of provision do you have on downstream discharge to catch the material removed so it doesn't cause more issues further downstream? I think you've already kind of touched on this, Paul, but if you can.
Yeah. Every now and again, the operator, the pipe owner doesn't want all this discharge to go into the gravity and potentially cause more problems in the gravity system that the force mains. But it's just a simple thing, as I said, if, we'll have a vac truck on standby there, and as soon as the ice arrives, the vac truck will start sucking out all the debris that's come with it, and it can be transported away safely that way. So there's always a solution for that, and that's nothing to worry about.
Yeah, if I can add on to that, Blake, if you noticed in the picture when we were talking about the Country Lake Force Main, we actually did have a combination vac truck sitting there sucking up the ice as it was going through so it wouldn't go downstream into the collection system. Which, being an operator, it was actually very easily to do, but we also went one step further, and we actually cleaned the collection system, that downstream pipe, one manhole downstream, to confirm or make sure nothing went down, that we did not catch, or everything was caught down. Nothing went downstream that was going to cause an issue. That's what I'm trying to say.
Gotcha. That's great. Thanks, Tony. Next question, what pressure flow do you pump at? They're used to doing mechanical pigging and keeping the pig at a certain feet per second.
Well,
Paul.
if I can jump in there, to the ice pig doesn't care. The ice doesn't matter whether it's going through quickly or whether it's going through very slowly. So in other words, we only ever need the normal operational flows and pressures of that system is normally going to be totally adequate to push or flow an ice pig through the system. There are times on smaller sewer force mains with small pump stations, smaller diameter pipes, where we may need an external booster pump to help the ice along if the lift station pumps aren't up to it. But we certainly don't need any excess force or pressure to push the ice through. Again, it's just like a liquid, and it'll flow like a liquid.
Thanks, Paul. Next question, what is the longest run you can run with ice pigging before it's melted and not aggressive on the pipe?
That depends totally on the pipe diameter, the size of the pipe, and the pipe material. The pipe material, because a metal pipe, the ice will melt quicker than what it will in a plastic. And the pipe diameter, just purely because of the volume of the pipe, as I said, we make a 10-ton batch of ice, and we'll clean with that as much pipe as we can every day. I can tell you the longest run that we've done in the United States was 2.3 miles of 6-inch PVC pipe, to give you some idea. And when we did that run, incidentally, there was quite a lot of ice came out. So that ice would have gone even further, probably would have gone almost 3 miles. But as you step up in pipe size, then the distance you can push that ice, dramatically decreases. I hope that gives you some idea.
No, that's great. Last question that I see is there any concern with the salt increasing the corrosion on metal pipelines, or does the quick wash after mitigate that concern?
Yeah, the end of that question is the answer. the salt is not having long enough contact time, and it's all flushed out of the system, and therefore it doesn't have any effect whatsoever for corrosion.
Okay. Any issues with asbestos pipe in both drinking water and wastewater?
No, as long as the pipe is in sound condition in the first place, and then the ice is not going to harm or damage. The ice is a very non-aggressive cleaning tool. That's why it's not perfect every time. Sometimes it's not aggressive enough to clean hard substances from a pipe. But for the same reason, it's not going to damage any pipeline in any, assuming that the pipe is in good condition before we start. Now, with asbestos, if the asbestos were very flaky before we start, and then the ice is likely to pick up some of that and take it out with it. But you know, if that's ever a concern of a pipe owner, then they need to, you know, I don't know what the answer is, because if you put a conventional pig down there, it's going to be even more aggressive. So you've probably got a problem if you've got pipes that are starting to fall apart or disintegrate.
Okay, great. Thanks, Paul. Another question. Can you discuss how you know that you've reached the point where the pipe is considered clean?
Well, that's a great question, and I'd like to jump in, but then I'd like to hear Tony's viewpoint on that as the pipe owner in this case. What I say is, if in sewer force mains, you're nearly always going to see, as you saw the results from Tony's operation there, the pumping performance. Now, Tony might not know that that pipe's perfectly clean. However, if the pumping performance is taken back up to what the design specifications were after a pipe cleaning, then that's generally going to be a good indication that the pipe's perfectly clean. In drinking water, it's slightly different. There's a different phase in the drinking water cleaning where we take samples of the ice as it's being discharged. And we can fill these sample bottles up, clear sample bottles, and then we can see the ice coming out cleaner and cleaner. And that's what indicates to us that the pipe is now nice and clean by the samples that we've taken at the discharge end. But as I said, with sewer force mains, you're just purely looking at the increase or in the pumping performance. Have you got anything to add to that, Tony?
Yeah, actually, a couple things that we looked at to confirm that the pipe was clean, besides the pump performance, was actually the discharge. If the pipe is blocked, your discharge flow does not travel, shoot into the manhole as far as it would if your pressure and your flow from your pumps increased. So in both of these projects, we can actually see the water coming as the pipe was getting cleaner and cleaner, the water was coming out faster and faster. And that's how one of the reasons we determined that, hey, this force main is actually getting pretty clean and is clean. But you can also tell by the color of the water if the force main is relatively full of debris and stuff, you can see that it's got a lot of bubbles in it. It's a little bit darker than the water that's in the wet well that's being pumped. But in both of these projects, as the force main was getting clean from the ice slug, the water, obviously, as the ice was getting closer, the water was getting darker, darker, and darker. But by the time that the ice made it through, the water was exactly the same color as the water in the wet well. So those are, besides the pumping and the pressure monitoring, those are the two other factors that we confirm, hey, this one application actually did clean the force main.
Great. Thanks, Tony. This one's for you, Paul. Have you found it necessary to pig a sanitary main twice?
That's a good question, and I'd have to really rack my brain there. But no, I don't believe we've ever needed to do a second run on a sewer force main.
Okay. What if a wet well collection system does not have enough flow to purge the force main of the ice pig?
Good question. And quite simply, we need to make sure that it's going to have enough flow. Quite often what we've done in the past is have a fire hydrant with a hose connected to a local fire hydrant and have that just fill in the wet well up to ensure that, because it's very important that you keep those pumps running until all the ice has got to its intended destination. What you don't want to happen is the wet well to, or the pumps to go to cut out on low suction because the wet well's gone dry. And then the ice just gets dumped where it is. And by the time you get the pump started again, that ice may have melted or whatever. So that's very important consideration and something that's done in the planning stage. But like I say, you just need an extra water supply from somewhere. Sometimes we may even have a fleet of water tankers on standby to pump water into a wet well if there's no drinking water fire hydrants around.
Yeah, I can add on that as well. Actually, what Paul explained was exactly the situation we had at Cinnamon Creek. The flow at Cinnamon Creek was minimal, so we actually ended up hooking a hydrant up to and flowing into the well from a nearby fire hydrant to keep the wet well capacity up enough where we can keep pumping water. So it actually worked really well using the extra water from a fire hydrant.
Okay, great. Thanks, Tony. Last question I see is there any expectation in the future to increase ice load to extend the run length, bigger ice maker, et cetera? And Jan, I'll answer this, which is we are looking into acquiring and commissioning another rig to be able to offer larger diameter pipes and to go further. And so we're hoping to have that possibly as a solution by the end of this year, but it's still a few things up in the air, so we'll see. Does anybody have any questions that they have not typed in yet, either in the Q&A or in the chat box? We'll give it another 5 to 10 seconds. Okay. I just want to thank everyone again for taking the time out today to attend this webinar. We are looking to, we got one last question. What is the max diameter pipe that we currently can ice pig?
Well, to answer it direct, the largest pipe that's been cleaned in the United States was 42 inch. But that's really getting to the extremes of our ice making limitations. As Blake said, you know, we are working on increasing our ice making capacities so we can do larger pipes. I don't think even then that anything over 42 inch will be fair game. You know, we need to look at other methods of mechanical pigging when we get that large, but anything as small as 1 inch up to really 24 inches is becoming the getting us out of our comfort zone, anything larger than 24 inch. But that said, we've cleaned several 24 inch pipes very successfully when there's been no other option but to use ice pigging. So I hope that answers the question.
No, perfect. Thanks, Paul. All right, well, we're going to wrap it up. And just a reminder that we're going to be doing a webinar, one webinar per quarter. And the next one will be on smart pigging, condition assessments for both water mains and force mains. So if you're interested in attending that, please drop your contact info in the chat and we'll make sure that you get the invite whenever we finally set it up. But again, thank you for everyone for taking the time to attend this and have a great day.
Thanks, everyone.